Plenty of animals build their homes in oak trees, but it's another thing entirely to get the oak tree to do all the work, to build your house for you. Say you're an oak tree, just sitting there minding your own business, when suddenly this tiny wasp comes along. She says, "Hey, why don't you build me a nursery for these baby wasps I'm about to have?" And then she injects her eggs under your skin. You find yourself creating an entirely new structure, one you would have never built for yourself. What nerve, you might say? What gall? And you'd be right. This thing, this parasitic wasp house, it's called a gall. There can be dozens of types of galls on a single tree, each one built to order for a specific species of wasp. They're called gall-inducing wasps, and each gall is weirder and more flamboyant than the next. Sometimes the wasps prefer a mobile home. This one is called a jumping gall. It falls from the tree and bounces across the ground like a Mexican jumping bean until it finds a safe place to hatch. As a protection against predators, galls can taste incredibly bitter. Bitter like the bile produced by a gall bladder. In fact, the earliest doctors believed being bitter and angry meant an excess of gall in the body. Anyway, back to our tree. Inside the gall, the larvae mature and develop, and as they grow, they release chemicals that tell the tree how to build the gall. The tree is tricked into funneling nutrients into the gall to feed the hungry wasp larvae. Scientists call this a physiologic sink. For the larvae, it's like living inside a giant banana, an endless supply of food. But the peace and quiet don't last long. All that free food starts attracting uninvited guests. That original wasp itself becomes a host for another set of wasps called parasitoids. One study in the UK found 17 different wasp species living in one gall. But the oak tree, it does just fine, in most cases unharmed by the tiny rivalries in tiny houses on its branches and its leaves.
It's one thing to provide food and shelter in return for protection, but it's quite another thing to be compelled to provide a home where before there was none. But some insects have the ability to force a plant to do just that. They're called gall makers, and this oak tree is infested with them. This odd wrinkled object at the base of an acorn is known as a knopper gall. Inside, there's the tiny grub of a minute wasp. To understand how it got there, we have to go back to last spring. This tiny insect, scarcely bigger than a mosquito, is one of these gall wasps. There are lots of them flying around the oak flowers. Most of the flowers by now have been pollinated and are about to develop into acorns. The gall wasps too have mated, and this female is looking for a place to lay her eggs. She thrusts her ovipositor into the base of the fertilized flower and injects an egg. And that triggers a profound genetic change in the growing oak bud. It develops not into an acorn, but into something very different, a gall. Within, the tiny larva whose secretions have caused the change feeds on the oak tree's tissues. As summer proceeds, the galls become increasingly hard and woody. Autumn comes, and the oak tree starts to shed its leaves. It's shutting down for the winter. And with its leaves go both acorns and galls. Plant and insect life is suspended. But unseen changes are nevertheless taking place. Spring comes at last. Inside the gall, something starts moving. The larva has turned into an adult wasp. It has spent 9 months within the oak tree's tissues. It has only a few weeks of its life left. Now, as an adult, it must look for another oak to inject with eggs. A single oak tree may be afflicted by 70 different kinds of gall, each produced by a different species of wasp, and each with its own particular contorted shape. These hard shells may seem to be effective defences for the little grub inside them, but not necessarily so. This is another kind of gall wasp, and she's not a genetic engineer, she's a burglar. Behind her she trails her equipment for breaking and entering, a drill. She carefully selects a site for her operations and takes aim. She flicks away the drill's sheath and starts work. Her aim has to be very accurate if she's to strike her target, the larva at the gall's centre. The tip of her drill has a sharp cutting edge of metallic zinc which pierces the gall tissues with ease. When she detects that she's reached the central chamber, a microscopic egg travels down the centre of the drill and into the larva. The operation is over. Her offspring will now hatch in the gall's centre, consume the flesh of the resident larva, and take over the gall.
5 years ago, a gall wasp began killing off coral and willy-willy trees across the state. A tiny wasp, it was inflicting major damage. It was infesting tens of thousands of trees statewide, first by laying its larvae, causing galls or deformities on the plant, and then eventually killing off the trees. The big coral tree at Tamarind Square survived only because of regular systemic treatment. It is the exception rather than the rule. So the Department of Agriculture found a natural predator. It ran a series of tests and then released the Tanzania wasp brought in to bring the gall wasp under control.
It lands on there, and when it finds a gall, it inserts its egg next to that gall. And her egg hatches out, and then her larva, or her young, then starts mining through the leaf, eating all the bad gall wasps that are in there.
Entomologist Juliana Yalamar is watching it happen under her microscope. She collects galls from different locations around the state and is able to determine where the gall wasp still thrives and where the Tanzania wasp has begun to control it.
Our sense is, yes, it is helping a lot. We've seen, for example, some of the introduced coral trees, we've seen much less galling on them. Everywhere we're looking, pretty much everywhere we're looking, we're finding the parasite that we released, and it's in good numbers attacking the gall wasp.
The plan is working. The Tanzania wasp will probably never completely kill off the gall wasp, but the good wasp will dominate the bad wasp to the point you won't even notice it's there.
It's not a mushroom, but it's still something really interesting. I sometimes like collecting these. They can be really pretty colors. What this is called a gall, and essentially it's a little home for baby wasps. The wasps come and they secrete some kind of saliva on the tree, and the tree has a hormonal change, creates these galls where the baby larvae are, and then eventually they break out. And sometimes you'll see these everywhere all over the ground, and sometimes people will send me photos of these and ask, what kind of mushroom is this? It's not a mushroom at all. It's a little baby wasp inside there. Pretty neat little things. And that one's very common on oak. It's actually called an oak gall wasp that does that on those trees.
The continuous movement of goods and people has unfortunately led to the introduction of various plant and animal species that were brought in by accident. In their new environment, they have multiplied and spread, sometimes severely disrupting ecosystems. In recent years, some particularly dangerous species of insects, the Asian longhorn beetle, the chestnut gall wasp and the western corn rootworm, have arrived and spread in Lombardy. The chestnut gall wasp, Dryocosmus coryphulus, is a tiny wasp originating in China, reported for the first time in Europe in 2002. It was first found in Lombardy in 2006. It's a specific parasite that spends its whole life cycle exclusively on chestnut trees. The population consists only of females, small wasps with black bodies, fat abdomens, and brownish-yellow legs. The life cycle lasts only 1 year, and there are no males. The young larvae spend the winter in the buds. In the spring, the second stage larvae form galls, roundish outgrowths with a smooth glossy surface, green at first, and then gradually turning a reddish colour. The galls are rather striking, clearly visible both on the leaves and on the shoots. They can block the vegetative development of the affected buds and reduce fruit production by killing the flowers. The chestnut gall wasp arrived in Lombardy presumably on infested chestnut plants, and unfortunately in just a few years has spread to all of our forests, creating understandable concern. Due to its devastating effects, here at the Plant Health Service we treat the chestnut gall wasp as a quarantine pest, which means mandatory controls. Given that insecticides are fairly ineffective but have a huge environmental impact, biological pest control is currently the best solution. So that is the type of pest control we have been carrying out since 2008, releasing the wasp Pteromus sinensis, an antagonist from China, into the woods of Lombardy. This will gradually lead to the insect being kept under control biologically, as is already happening in Japan. Our phytosanitary inspectors constantly monitor the spread of the gall wasp and its parasitoid.
See, right in this branch here, there's a history of the infestation.
Thank you.
We hope to collect twigs with the gall wasp in them, and then we will dissect the twigs back over several years worth of growth to learn about how the infestation has changed over the last several years. So we know the infestation has been cooking here for some years, and we hope to recreate the history of that infestation by dissecting the twigs and counting the number of live adults, the number of exit holes, the number of galleries that were formed by immature gall wasps that failed to survive to adulthood and produce exit holes. So in this way we can get a fix on the changing population over time.
The wasp creates these cavities, these holes right here, and it plants its eggs in there. They develop into larvae. They turn into pupa, which I might be able to find right here. This looks like a pupa, which is a hard shell.
That's her best one yet.
And then it becomes a fully formed adult. So now the question is, when does this adult emerge?
The problem is really severe. It's caused thousands, if not hundreds of thousands of trees to die here on Martha's Vineyard. So you can show you aerial photos with lots of dead trees. And what's even scarier is that the trees take a long time to die. So we could have many trees die in the future that are infested, but they look healthy now. So we know this problem has spread to Rhode Island, it's spread to Cape Cod, and it's affecting black oaks in particular in all of those locations. That is the main hardwood tree in all of those regions. So it's
a very severe problem, and we need to understand it as soon as we can if we're going to have any hope of doing anything about it.
Keep going. Yeah, let's keep going.
This tree behind me is been infested with what is called the crypt gall wasp. It is a small insect that lays eggs at the ends of the branches, and the larvae that emerge from the eggs mine into the branch and create these cells. And it appears that this enlargement or gall that is created by the insect shuts off the movement of water and nutrients to the leaves that are in front of it. And without those nutrients and water, the leaves die, and resulting in dieback of the tree. We're hoping that by applying the product in the fall, that we will fully protect the tree by the time the insect emerges to lay eggs in the spring. The tree should begin to recover from the attack and put out new leaves.
This one over here. This is actually a grapefruit, and if you look carefully here, you'll see these horrible looking swollen bits along the stems. That's citrus gall wasp. It is a nasty pest, and the best way to control that is to prune those bits off and put them into the garbage. So prune them off. You don't throw this in the compost heap because there's little wasps and that will come out. Inside each of these galls there's one or more maggots. They're the baby wasps. They sit right in the middle of it and they're just waiting to grow up, tunnel their way out and go and wreck everyone else's citrus trees in the area.
Das ist sie jetzt also, La Regina dell'Autunno, die Königin vom Herbst, wie man der Kastanie im Tessin auch sagt. Und es hat wieder überall in den Wäldern und sie sehen gut und genießbar aus. Wir sind in einem Wäldchen oberhalb von Bellinzona. Marco Conedera, Forstingenieur. Wie geht es den Bäumen? Was sehen Sie?
Es geht eindeutig besser. Sie sind am Erholen, dank der Feind der Gallwespe, der natürlich gekommen ist und seinen Job wirklich gut gemacht hat. Man sieht es hier an diesem Ast, wie die Situation vorher war. Also der Baum wurde von der Gallwespe gezwungen, diese Gallen, diese Häuser für die Larven der Gallwespe zu bilden. Diese Gallen haben praktisch den Trieb nicht mehr erlaubt, normal zu wachsen. Und dadurch ist eine korrupte Astarchitektur geworden.
Und was hat das bedeutet fürs Tessin?
Also man muss sich vorstellen, praktisch jeder Baum im Tessin war befallen. Dadurch waren die Kronen transparent und der Baum hat gelitten. Das hätte mittelfristig zu Problemen bei der Gewährleistung der Schutzfunktion der Wälder gebracht.
80% von allen Bäumen im Tessin unter 1000 Meter sind Kastanien. Alle bedroht vom Gallwespe, der seinerseits bedroht ist von einem Schlupfwespe. Italien hat ein neues Insekt aus Asien importiert zum Schutz von seinen Kastanienwäldern und jetzt wandert das in die Schweiz ein. Das wollen wir uns genauer anschauen. Wir machen uns auf den Weg ins Labor von der Eidgenössischen Forschungsanstalt für Wald, Schnee und Landschaft zu Bellinzona. Und das kleine Viech da macht also der schädliche Gallwespe der Gar aus und das erforscht der Erik Gehring hier als wissenschaftlicher Mitarbeiter. Was sieht man hier?
Was wir hier sehen, ist, dass der natürliche Find, das Schlupfwespe, sich breit gemacht hat. Und zwar quasi im Zimmer des Gallwespe. Und dort frisst es die Larven von dem Gallwespe und wächst selber in dieser Galle.
Und so überleben viel weniger Gallwespe, aber das neue Insekt könnte es nicht auch Schäden anrichten?
Also die möglichen Schäden, die Schlupfwespe machen können, sind, soweit wir das heute wissen, sehr viel kleiner als die Schäden, die das Gallwespe an den Kastanienwäldern anrichtet. Bis jetzt sieht es dann noch aus, als ob der natürliche Find nur der Gallwespe schadet.
Und sieht man denn schon jetzt, dass das nachhaltig hilft?
Ja, die ersten Resultate, die wir hier im Tessin haben, dieses Jahr sind sehr gut. Und in Italien sieht man schon ausgezeichnete Resultate seit mehreren Jahren.
Allora, grazie mille. Arrivederci. Und jetzt ist es Zeit, dass wir die Maroni abliefern. Kastanien sammeln können im Tessin nämlich alle, die Freude daran haben. Und viele Leute bauen auch ihre eigenen Wälder an und verkaufen sie dann bei einer der beiden Tessiner Sammelstellen. Je nach Qualität gibt es für ein Kilo zwischen 1 und 3 Franken. Wir sind jetzt in Cadenazzo, gar nicht weit entfernt von dem Wäldchen ob Bellinzona, wo auch wir unsere Kastanien haben gesammelt. Und die Sammelstelle leitet durch Paolo Bassetti. Herr Bassetti, wie läuft das Geschäft?
Im Moment besser als die letzten Jahre. Wir sind froh. Auch die Qualität der Kastanien ist etwas besser. Es hat auch wieder größere Kastanien im Vergleich zu 2013, 2014. Die waren ganz schlimm.
Was hat denn diese Kastanienkrise in den letzten Jahren bedeutet?
Also ein Mangel an Ware und das ist schade gewesen für unser Projekt, weil wir haben es aufgebaut. Es hat einen guten Anklang gehabt in den Kunden und so und wir müssen alles zurückdrehen. Es ist schade und jetzt hoffen wir, dass wir in den nächsten Jahren wieder aufsteigen können.
Jetzt gibt es also wieder mehr Kastanien. Was wird jetzt aus diesen?
Aus diesen hier, die kleinen, machen wir Mehl. Also die werden getrocknet und dann geschält, sortiert von Hand, weil man nichts anderes machen müssen. Diejenigen, die Pilze und so haben, müssen raus und dann machen wir Mehl.
Grazie mille, Herr Bassetti. Also, als Mehl ist die Kastanie über Jahrhunderte hinweg das Grundnahrungsmittel von den Tessiner, das Brot der Armen sozusagen. Heute ist die Regina dell'Autunno, die Königin vom Herbst, ein Luxusprodukt, das sich langsam aber sicher erhält.
I can show you an oak leaf with the galls.
The other collection housed in these cabinets is the gall wasp collection of Alfred Kinsey, who studied gall wasps.